Hello friends, let's look at this amazing and interesting Olympiad math problem. Okay, now it says find the values of m and n that satisfies the equation 5 raised to power m is equal to 5 raised to power n plus 620. All right, now I want you to pay very close attention to this problem because it is very technical. Okay, now the first thing we're going to do here is to transfer 5 raised to power n to the left-hand side of the equation. And remember that when it crosses the equality sign, it will take a negative value. So we're going to have 5 raised to power m minus 5 raised to power n is equal to 620. All right. Now, this is the first step. Now, for the very fact that 5 raised to power n is subtracted from 5 raised to power m and the result is a positive value, it then means that 5 raised to power m is greater than 5 raised to power n. This is simply because 10 minus 8 will give us a positive value of 2 because 10 is greater than 8. So if 8 is subtracted from 10 to give us a positive value, it then means that 10 is greater than 8. Because if the numbers are swapped around, then it will give us a negative value. For instance, 8 minus 10 is equal to minus 2. So if 8 is subtracted from 10 and it gives a positive value, it means that 10 is greater than 8. So in the same way, if 5 raised to power n is subtracted from 5 raised to power m and it gives us a positive value, it means that 5 raised to power m is greater than 5 raised to power n. Okay, now in this case, it then implies that m is greater than n. Okay, now if m is greater than n, it simply means that something must be added to n to give us m. Now let us assume that that thing is p, for instance. So we have m is equal to n plus p. Now, if 10 is greater than 8, it then means that something must be added to 8 to give us 10. So we have 10 is equal to 8 plus that number that must be added to 8 to give us 10, and that number is 2. So here now, let us assume that that number that must be added to n to give us m, let us assume that the number is p. Okay, now, having arrived at this stage, what we are going to do now is to substitute the value of m as n plus p in this equation. So that means that anywhere we see m in this equation, we are going to replace it with n plus p. So we have 5 raised to power n plus p minus 5 raised to power n is equal to 620. All right. Now, I hope you are getting what we are saying. Now, here, we are going to apply the simple laws of indices. Remember that a raised to power b plus c is the same thing as a raised to power b multiplied by a raised to power c. Okay, so that's what we have here. So that means that 5 raised to power n plus p is equal to 5 raised to power n multiplied by 5 raised to power p. Then minus 5 raised to power n is equal to 620. Okay, now remember that here now, 5 raised to power n is common. So what we are going to do now is to factor it out. So we have 5 raised to power n, then put a bracket and place whatever that remains inside this bracket. Now what remains here now is 5 raised to power p minus what remains here is 1. Because 5 raised to power n times 5 raised to power p will give us this. And 5 raised to power n times minus 1 will give us minus 5 raised to power n. Now this is equal to, now this 620, we can bring out the factors of 620. And the factors of 620 are 5 multiplied by 124. Because 5 times 124 will give us 620. Okay, Now, what we are now going to do here is 5 raised to power n into 5 raised to power p minus 1 is equal to, now we are now going to express this 124 in index form. So we shall have 5 raised to power 1 multiplied by 5 raised to power 3 minus 1. Because 5 raised to power 1 is the same thing as 5. And 5 raised to power 3 is 125. 125 minus 1 is 124. All we want to do is to establish a relationship in which case the variables on the left-hand side can be correlated with those on the right-hand side. So now, in this case now, it means that 5 raised to power n is equal to 5 raised to power 1. And 5 raised to power p is equal to 5 raised to power 3. So we now have 5 raised to power n is equal to 5 raised to power 1. And remember that this is an index notation. Because they are on the same base, we neglect the bases and equate the powers. So that means that n is equal to 1. Also, 5 raised to power p is equal to 5 raised to power 3. 5 raised to power p is equal to 5 raised to power 3. In this case, because the bases are the same, we neglect the bases and equate the powers. So p is equal to 3. Okay, so n is equal to 1 and p is equal to 3. But remember that in this equation, we are asked to find the values of m and n. So what we are now going to do is to substitute n equal to 1 and p equal to 3 in this equation we have established. So from there, we are going to have m is equal to n plus p. M now is equal to, n is equal to 1. So we have 1 plus p is equal to 3. We have 3. So that means that m is equal to 1 plus 3 is 4. So that means that in this very equation, the value of m is equal to 4 and the value of n is equal to 1. Now, in order to make assurance a double sure, we now substitute the values of m and n into this equation to see if the equation is satisfied. So remember that m is equal to 4 and n is equal to 1. So here we have 5 raised to power 4 minus 5 raised to power 1. Let us see if the result will be 620. Now, 5 raised to power 4 is equal to 625 minus 5 raised to power 1 is equal to 5. And 625 minus 5 is equal to 620. So it has been confirmed that the value of m is equal to 4 and the value of n is equal to 1. Thank you very much for your audience. Please don't forget to share our videos and subscribe to our YouTube channel. God bless you.